So you're interested in living on Mars. It sounds fascinating, but the reality is that it's one of the most complex, dangerous, and expensive endeavors in human history. Imagine constructing Rome, launching Apollo 11, deploying the ISS, and settling North America, all happening simultaneously, 150 million miles away from Earth on a frozen desert rock in space. Colonizing Mars will require an unprecedented collaboration in space exploration history, with NASA's established expertise and SpaceX's innovative drive joining forces to overcome immense challenges, defy the Fermi paradox, and make humanity a multi-planetary species. Here's how they plan to achieve this. Elon Musk often talks about a window in time. Life on Earth has existed for over 3 billion years, but only now have we developed the technology to leave our planet and visit another. This makes our generation unique and gives us a significant responsibility. This window of opportunity has opened for the first time in billions of years, but we have no idea how long it will remain open. If we miss this chance, it might never come again. In the best-case scenario, Earth has another billion years of habitability. In the worst case, it could all end today. The drive to explore the solar system and discover new worlds is fundamental to our nature. We are explorers and survivors, and it's encoded in our DNA. All we need is a way to get there. This principle guided Elon Musk when founding SpaceX 2 decades ago. We know humanity has the will to explore. SpaceX just needs to provide the way. This vision has now taken shape in the Starship Super Heavy rocket, the first vehicle designed to address the fundamental problem of sending people into deep space. A journey to Mars requires bringing a lot of supplies, and putting that mass into space requires immense power. The most powerful rockets to date, NASA's Saturn V and the Space Launch System, were built to send humans beyond Earth. Saturn V could deliver 50 metric tons to the Moon, enough for a 1-week mission for 3 astronauts. Now consider the mass needed to support a crew of 10 on a 2-year round trip to Mars. This is why the Starship Super Heavy booster generates more than double the thrust of the Saturn V. This monumental increase in rocket capability is only in the prototype stage, and SpaceX is developing even more powerful engines. Early versions of the Raptor engine aim to send 100 metric tons to Mars, a figure likely to increase with future Starship designs. However, if we use the Apollo missions as a benchmark, the Mars mission needs more than just 3 times the capacity. This is where Starship's revolutionary concept comes in. It's not just about power, it's about numbers. NASA built 15 Saturn V rockets and launched 13, sending 24 astronauts to the Moon. Starship needs to drastically increase both power and production. Instead of 1 Starship, we send a fleet. SpaceX aims to build 1 Starship every day, not as a boast, but as a necessity. Musk envisions 1,000 Starships operating between Earth and Mars. In 2022, there were 180 rocket launches worldwide. Musk's fleet would surpass this by 5 times, just in Starship launches, carrying significantly more mass. Elon's ultimate goal is to transport up to 1 million metric tons to Mars, enough to establish a self-sustaining city. This is the scale needed to ensure we never revert to our previous state. But even with its potential, Starship alone isn't sufficient to colonize Mars. The vehicle needs help from the pioneers of spaceflight. Much like Luke Skywalker required Yoda's guidance, SpaceX needs the expertise of NASA to make human travel to Mars viable. The key to unlocking greater efficiency for Starship lies in nuclear thermal propulsion. By using a small fission reactor to split uranium atoms and release energy as heat, liquid hydrogen pumped into the reactor core expands into gas and exits through a nozzle, creating thrust. This method promises 3 to 5 times the efficiency of chemical rockets, translating to faster travel, more payload capacity, and better maneuverability in space. NASA has been exploring this technology for decades and is now aiming to deploy a nuclear spacecraft within 5 years through Project Draco. While the timeline is ambitious and building a new vehicle in that time frame is unlikely, NASA could develop a nuclear engine. For SpaceX, access to nuclear fuel for rocket experiments is heavily regulated and costly, making government involvement crucial. A partnership where NASA provides the engine and SpaceX, the vehicle could lead to a nuclear-powered Starship, the ideal transport between Earth and Mars. Nuclear power has additional benefits for Martian colonies, offering reliable energy where solar power falls short. NASA's Kilopower project, a small modular nuclear reactor, could provide abundant energy for Martian outposts. NASA plans to test this technology on the Moon by the end of the decade. NASA also excels in logistics, an area where Musk has less expertise. Establishing a Mars city involves complex planning, project management, and understanding human factors in isolated environments. NASA's Mars Dune Alpha, a simulated Mars habitat, is a step in this direction. By placing crews in these simulators, NASA gathers essential data on human adaptation to space colonies. NASA brings decades of Mars research experience, making them indispensable. While the idea of a lone genius colonizing Mars is appealing, it would likely end in disaster. SpaceX needs NASA, and NASA needs SpaceX. Together, they might just make colonizing Mars a reality. If you enjoyed this video, please give it a thumbs up to help us reach more viewers. For more content, consider subscribing to our weekly newsletter. A big thank you to our Patreon supporters who make our content possible. Thanks for watching and see you in the next video.